Hi, welcome to TechCrunch, a place where we learn and earn technical skills in the most efficient way. Let's make coding fun. Java Coding Exercise Series 1, Armstrong. So in this session, we are going to learn how to implement and check whether a number is Armstrong or not with live demonstration in Java. So before we get into the implementation, let's first learn what is actually an Armstrong number. Armstrong number is a type of a number which is an n-digit number that is equal to the sum of the nth powers of its digits. This will be more clear when we actually work it and see the examples, but to understand it, the concept and the algorithm, which is not related to any kind of real world application, is just for good for practice, logic and algorithm. Now let's see what is actually an algorithm of Armstrong number. So if you see an example of 153, just take an example of number. But as per the Armstrong, that means you have a number and you split into the digits and you make an nth power of individual digits and sum of them, and that will come up the same number. So this is what the Armstrong. To understand it better, let's take a look at the example of 153. So what is it happening here? You split this number into digits. So 100th number is your 1 and we cube of it. It's not necessary for the cube. If it is a square or fourth root or fifth root, it completely will come in the Armstrong number. So we are just taking an example of cube for now. That's what the means of nth number of the power. So here cube of 1 and sum of cube of 3 and sum of cube of 3. If you elaborate this expression, it will go like this: 1 multiplied by 1, 1 multiplied by 1, this is 1 cube. Sum of 5 multiplied by 5 and 5 multiplied by 5, sum of this, and then cube of 3, 3 multiplied by 3 and 3. So if you sum of these, if you see 1 multiplied by 1 is equals to 1, cube of 5 is equals to 125 and cube of 3 is equals to 27, and if you add all these three numbers, that will come the same number what it is, 153. Going to do in the implementation, as you can see here, we are considering right now for the cube to make it simple. And we are going to have a counter and a temporary number and some variables. We are going to get the value from the user to check if it is Armstrong or not with the help of the scanner util API. And we are going to assign the number as an n and temporary initialize it with the variable temp so that we can swap and we can process and compare it with the counter. And we are going to put it in a loop, and the loop will go until the nth number which you gave entered has to be 0. And in the first, we are going to split. So the splitting of the number into the digits is going to be happen in the variable a, n modulo 10. And when after that we have to keep splitting it, so we are going to divide it into 10. And the 8th now variable will be your the first digit, so it will be like 1 multiplied by 1 multiplied by 1, and counter will simply compute and accumulate your sum, and in the end you will get the result of sum of all the cube number of the digits is going to save it in C. So the 10 is the real number and C is your sum number, and if they are same, then it is Armstrong. So this is a very simple algorithm and its implementation in Java. Now let's take a look at the demonstration. So this is my Eclipse IDE, and here I'm going to just have a small class file in my simple Java application. And here is my source and default package. Just have an Armstrong demo, and I can have my main method here. Excuse me. And let's first import our java.util so that we can have the value from the user. A scanner will be able to help you to get the value from the user. So let's just define it and initialize with your scanner. And once this is done, the next will be your int n. Your n number is equals to in dot next. So before that, we have to ask user to enter the number to be checked for Armstrong. Enter number to check for the Armstrong. Now once this is done, then let's have our variables initialized. Your for while loop, like counter, which is equals to 0, temp, and your a variable. Now once this is done, your n which you have entered is to be greater than 0, and after that you can just simply modulus it and initialize it to your temp. Now inside the while loop, what we have to do is we have to assign and get the splitting the number into the digits. That is happening with the help of modulus 10. Now once this is done, then again we need to split into until it is not single digit. Now once this is done, next we need to add and cumulate the sum. So a result of all kind of addition. So a is your first digit, and you see you need to have a cube of it and sum of it. So once this is done, after that you can check if your temp is equals to C. If the sum and the number is same. If it is same, the number is Armstrong. Else not Armstrong. Maximum, you can just print the variable temp. Now if you see the execution, it's very simple. So 153 hour the very first. So we have done implementation of Armstrong. Now I have a simple improvised version of this algorithm. What we are going to do, I just wanted to add one more feature in this program. What we are going to do here now, and here we can just get the value from the user and check whether the number is Armstrong or not. Now what if in case user wanted to know what all Armstrong numbers are there within a range? So next step, what we are going to do, we are going to display the numbers between the limit. So for that, we need to have a variable in a method. I'm just going to have a method and assign a variable. I'm just going to implement the same stuff in the method. Other than that, just going to be in a loop, this implementation, so that the method will just keep running until the loop will find out the all kind of Armstrong's number within the range. So first thing, we need to get the value from the user, the limit. So enter limit with the help of the same implementation. There is no change, it's just same. Now we are going to assign the limit variable with the scanner object with the next int method. Now limit variable contains your int number and the range from 0. Number is going to be just a number reminder. Num variable will be existing the variable, the number, and the remainder is going to store it in the rem variable, and the sum for the addition. just the same implementation. Now here we don't need to print. If you want, you can print some message. Strong numbers from 0 to limit, yeah, n range. It's just your labeling. Now next step, we are going to have a for loop which start from 1, or you can have it from 0, because 0 is also your by default Armstrong number, you see, and going to be equal to limit, and goes I plus plus for the increment, and here num is initialized to I, and within this for loop now we are going to execute the same implementation what we did in the Armstrong, because now num variable basically contains the number which you need to check for the Armstrong. So remainder will store it in the modulo computation, and then we'll add it equals to sum plus and multiplied your remainder, which is your rem variable. And once this is done, the next step will be your division. What we are doing it, num equals to num divide by 10, the third step. And now once this is done, now next step, instead of getting the return message that if it is remain Armstrong or not, we just need to print the numbers. So here, if sum is equals to I, all we need to just print the variable, just for the reference. These all are Armstrong numbers, and if it is not, then just sum is equals to 0, back to the reset value. And all we need to call this method in our main method. Since it does not have any return type or any argument, all just need to use it in a class. Now let's take a look at the execution. So this is the number, just your first checking. Now next we can have 5,000. You can see it is showing you all the Armstrong within the range. So this is the implementation of Armstrong numbers. So we have seen the live demonstration of Armstrong number in Java. There are so many ways with the help of do while loop you can practice arrays or control statements and implement the same algorithm in number of ways. Thank you so much for watching this video. Please subscribe to our channel and stay tuned for more upcoming interesting videos. Let's make coding fun. Thank you.